Process Analytical Technology, or PAT as it's known, is a vast subject, and today I would like to show you how a PAT deployment manager, such as synTQ, can greatly speed up and reduce the cost of your deployments. I'd like to begin the presentation with two slides that talk about the demands placed on a PAT infrastructure. When you start a PAT deployment, you may not realise how much data is going to be gathered. Now, a normal PAT system gathers a huge amount of data, and it all has to be gathered in a compliant way. I will go on later to talk about the size of the data sets that you may be gathering, but I'd like to stress here that the data must be compliant. If the data is not compliant with regulatory requirements, then I would argue that it becomes virtually valueless. Instrument and data synchronization. Again, very often this is overlooked at PAT, at the initial points of PAT deployment. Very often, to gather useful data, you must synchronize multiple disparate instruments together with univariate data sets. These must be synchronized for the data to be valid and useful. Instruments run at different speeds, and your univariate data will come in at different speeds. These must all be synchronized, and you need a PAT data manager to do this. Presentation of data, this is critical. If the presentation of data isn't useful to the operators, and your operators can, when I use that term generically, it can be a multiple number of different users, the information must be turned rapidly into knowledge. So you need a system that can quickly change the data to information and from information into knowledge. And rapid configuration of your PAT system. You need a system that can be deployed quickly. If your system takes too long to deploy, then your managers will lose interest, then the project may come to an end. Even if a small project comes to an end without success, then the whole deployment of PAT within the organisation may come to an end for many years to come. So it's very important to gather a very quick return on investment for every PAT deployment, and this is possible by using a PAT data manager. Also, when deploying a PAT system is the importance to be able to use the best of breed products on your system. You don't want to be tied to any particular instrument, you don't want to be tied to any particular MVA system, and you don't want to be tied to any particular control system. By using a good PAT data manager, you're free to make the choice of these instruments, of these MVA systems, and of your control system from the start, and those can be grown in the future. The second point is that you need an environment for the rapid deployment of PAT. I cannot stress enough, if you don't deploy PAT rapidly within your organisation, then there is a high risk of failure. You need a system that's scalable. You don't necessarily want to start out with a huge system. You want to start with a small system that can be grown as your knowledge and your confidence of PAT deployments grow. And what you want to do is maximise the IP and the investment in this small system so that all the knowledge can be transferred to a larger system. If you try to start out on a PAT journey without a structured approach, then the deployments will take longer than necessary. The data traceability may well be lost. You'll be relying heavily on a paper-based system. The implementation will almost certainly require bespoke software, and the cost of deployment will be much higher. We would also say that unless data is managed in a structured and compliant way, then much of your IP is lost. By this, what we're saying is that if your data isn't traceable, then you will have to repeat many of the experiments and regain all the data and store it in a traceable way so that in the future you can prove the value of this data to the regulators. So, having set the scene, I'd like to take you through the objectives of this presentation. Firstly, I'd like to describe to you some of the data management challenges, show you how you can use a system to turn data into knowledge, show how the PAT implementation speeds can be improved, to propose a practical structure that supports the timely and compliant implementation of PAT and promote the practical application of technology. So let's put data into perspective. Let's set the scene. Once in production using PAT, it would not be unreasonable to have, say, 6 off spectral instruments gathering data at, say, 1 read per second. If you're gathering data, say, 1024 points, then you may be gathering perhaps 12K per read, per instrument. There would be in addition univariate data. There would be in addition your predicted and derived data. There will be other data that's calculated on the fly. So if you're running 2 shifts 5 days a week, then you are looking at something in the region of 1.2 terabytes of data per year. And all of this must be gathered in a regulatory compliant way, and that can be used in real time and can be mined historically to provide you knowledge and information. And thus we would say that it is essential to take a structured approach to PAT data management, else your project is likely to fail. So let's move on to infrastructure challenges. Initially, you have the challenge of model building. Now, model building requires the assurance of that all instruments are correctly calibrated and referenced. Now, this may seem very basic and very obvious, but if you don't gather the GMP compliant assurance that all your instruments are correctly calibrated and referenced, then the data is valueless. The gathering and storage of multiple sets of experimental data will be necessary, and these, again, I keep on stressing, but must be stored in a GMP compliant way. You then have to gather samples when you're running the experiments, and these must be synchronized with the spectral data sources that you're gathering. The laboratory samples then have to be sent off and analysed. You then have to select the data sets and export these to your MVA package, and in addition you have to add any univariate data that you may want to add to the system. You then have to add the laboratory results that you've gathered from your offline analysis, and then you have model building. So you build the model in your preferred MVA package, and then of course you have to export that model and use it in the environment that you've created. And all of this, again, must be done in a secure environment with proper revision control. But there is another way to the manual method of model building. If you use a PAT data management system such as synTQ, then you're free to select the instrument of your choice, you're free to select the MVA package of your choice, and when you run these systems together, all the data that you're gathering, both the spectral data and the univariate data, are all automatically stored in a GMP compliant way in your database. Furthermore, there are automatic associations between the univariate and spectral data sources, and you can easily associate your laboratory data with the specific data source that was gathered when the sample was taken. All those data sets can then be gathered together, all the correct associations made, and the data exported to your MVA package of choice very simply and very quickly. Indeed, clients have stated that the improvement there in time can be 100-fold. You go from hours to minutes. You can then create your model in your MVA package of choice in the normal way, and then you can re-import the data directly back into synTQ with all model revision control happening automatically. You therefore have a full audit trail of all your data from source to completion, so that if you need that data in 5 years' time, 10 years' time, it's all available for your regulator. So now we move on to model optimization. Now, once your models are built, they have to be optimized. Now, this is a pet area of mine, I must confess, in that many projects seem to take a long time because the client is trying to build the optimum model. I would stress that the model has to be fit for purpose, but it will not be optimal because you cannot get the optimal model from day one. PAT embraces continuous improvement, so therefore, by definition, your model will not be perfect in day one. So develop a model that is fit for purpose and don't expect to have the ultimate model. However, getting back to the core subject is, if you're doing this traditionally, then you have to run multiple experiments, gather the data from each experiment, analyze the data, and iteratively improve your model. If you're using a PAT data manager, then you can run multiple models at the same time. So for example, if you have 6, 10, it doesn't matter, the number really doesn't matter. If you have a number of models that you would like to test, then with the PAT data manager, you can run all of these at the same time and gather the results automatically so that you can analyze the data both in real time and historically. This saves a huge amount of time and saves a huge amount of raw materials. Now that you have optimized your model or models, you need to develop your process understanding. Process understanding is critical to PAT. To develop process understanding, you will have to run experiments, probably DOE, in order to understand the mechanistics of your process. To do this, you will have to run your instruments, maybe multiple spectral instruments, maybe multiple univariate data sources, synchronize these data sets, bring them up to your models, and you may even need to synchronize data for feedback and feed forward. And also, in addition to all these data acquisition requirements, you also need real-time views into the process to see how input changes affect the predicted CQAs. That's critical quality attributes. You need the ability to select data views on the fly without affecting the process, because very often you need to do investigations in real time. You need the ability to mine the data in real time and also retrospectively, and the ability to rapidly, but I must stress in a controlled way, change your PAT method as your ideas develop and grow. Using a traditional technique, this is hugely time consuming, very difficult to control, very difficult to document. However, by using a PAT data manager such as synTQ, you can meet all of these requirements. You can synchronize all your instruments and all your data flows using a graphical method, which means you don't have to have software skills. You can control all your data flows in this way. Orchestrations or PAT methods can be modified quickly but in a regulatory controlled way. Development times are hugely reduced, as are raw materials, and the saving of raw materials cannot be overemphasized. You gather more in-depth knowledge of process understanding because of the operator interface views, because you have access to both real-time and historic views. And also there is the opportunity to run your experiments once again on historic data. Armed with process understanding, you now have to build the control models. The control models would be built using the interrelationships that have been derived during the process understanding stage. These would be traditionally built perhaps in your PLC or in your DCS system, which is perfectly acceptable within synTQ. However, whilst perfectly acceptable to use a PLC or DCS system, this does introduce another skill set into your team at this relatively early stage of development. Also, if you use an external control system at this stage, you have to arrange to pass the data from your PAT data manager into this control system. Again, whilst perfectly possible, this introduces some complexity, but there is another way. By using the correct PAT infrastructure, you can develop the control model within this system. This enables you to optimize the control model using the skills that you may have already on board. Provided the control models are tested in open loop, this also gives the ability for you to be able to test multiple control models at the same time. You can maybe close the loop on one control model, but obviously closing the loop on more than one is not possible. But in a similar way to the development of the process models, this allows you to more rapidly develop the optimal control model. When you've finished this process, then you may well want to deploy that control model or that control method onto your PLC or DCS system. This simplifies the migration so that your automation engineer now knows exactly what he has to implement in his system. And now that you have all your process and control models in place, together with your process understanding, you're able to run in production from a technical perspective. I stress technical because obviously regulatory is another issue. When you run in production, you will need to be able to ensure that all your instruments are validated, are calibrated, and are referenced correctly. You need to be able to configure the instruments correctly for each production run and have assurance that those configurations are in place. You need to be able to run all of your instruments and data acquisition systems in a synchronized way specific for that product. You need to be able to run feed forward and feedback control as necessary, and you need to collect all the data in a compliant way. And very importantly, all of the data that you collect needs to be in the correct form for real-time release if that is your target, which for many PAT deployments it is. You need to ensure that all the data is held so that you have full traceability of any component used in the system, whether that's a software component or a hardware component. So you have a full life history that can be shown to a regulator as and when required. You also need to be able to create batch or campaign results to support your real-time release. And when I say campaign results, this could well be the campaign results from a continuous process. If not using a PAT infrastructure, then this is all very difficult to achieve. You may well be using bespoke software and you will have to have a large paper-based system in place. But by using a PAT data manager such as synTQ, all of this work is greatly simplified. By definition, PAT embraces continuous improvement. Therefore, your production system must take this on board. To facilitate this, you need a method of easily synchronizing the laboratory samples with a vast amount of collected data. You need a method that enables the easy data selection for model optimization. You need good visualization of all the data to provide you with information and knowledge as to how the process is running. With the correct PAT infrastructure, you have all of this in place. So, to get a PAT system up and running, what do you need? You need a PAT data manager such as synTQ. A system such as this can gather all the data that you require from multiple disparate spectral instruments. It can gather the data from multiple univariate data sources. It can synchronize all of this data. The PAT methods, the orchestrations, can be configured in a graphical way. The data can be exported to your MVA package of choice. That can interface to a control system of your choice, be that an internal control system within synTQ or an external PLC or DCS system. You can implement feed-forward and feedback control. The system is flexible and extensible. You can grow it from a small single instrument, single unit operation system through to a full enterprise system. And the system is cost effective. Armed with your new knowledge in PAT, with synTQ you can grow the system gradually. For example, the next size system may use synTQ FM. synTQ FM can run multiple instruments at the same time and can run multiple models at the same time. All the PAT methods that you have used within synTQ Lite can be used within synTQ FM, so all of your IP is protected. As with synTQ Lite, synTQ FM can interface to your control system of choice, your instruments of choice, your MVA package of choice, your third-party historian of choice, your LIMS system of choice. You have total flexibility. With synTQ FM, you are able to run multiple instruments and multiple models at the same time. You are also able to fully configure the orchestrations in the graphical environment. The FM system that you're using in your pilot plant is then fully portable across to your production system. Having carried out extensive work in your pilot plant or your laboratory, you may now be in a position to deploy PAT in your production environment. synTQ FM is ideally suited to the production environment. It is fully extensible. As with the pilot plant system, it can interface to multiple instruments and run multiple instruments concurrently. It can interface to multiple models. In your production environment, you may have different control systems. synTQ can interface to all of these. You also have the facility to run web clients. You may want to bring web views up onto your SCADA system of choice. There's no problem with synTQ. This can be done. Furthermore, you may want to have batch reports or campaign reports. This is easily achieved using synTQ RS. synTQ RS is the reporting server and can produce web-based reports, printed reports, or archived reports for your batch and campaign. Now that you have PAT on one production system, you may want to roll this out across other production lines. This can be accomplished very easily with multiple instances of synTQ. So now we have a situation where we're using synTQ in your laboratories, in your pilot plants, and on multiple production lines. One of the key points here is that synTQ no matter whether synTQ Lite or synTQ FM, can interface to your reporting server, and also it can interface to your Enterprise Master. The Enterprise Master is the central database that stores all data. This is both configuration data and gathered data. Furthermore, synTQ Enterprise Master enables the simple sharing of models between multiple synTQ nodes. Therefore, a model that has been developed on one synTQ FM node could be shared with other FM nodes and with other Lite nodes. This enables the simple control of your models. Yet further, synTQ Enterprise Master can interface to other synTQ systems that might be in other factories around the world. Therefore, your PAT deployment has to be fast, it has to deliver high quality product, and it has to deliver a return on investment quickly. PAT delivers on all counts.